Good morning everyone. Welcome back to our channel Study with Adu. I am back here. I was not well for the past 2 weeks. After Christmas I was not at all well. I was bedridden. I was not able to get up, do videos, talk itself properly. I was about to be admitted in the hospital. So what happened is that I was not well, so I was not ready, or I was not I wanted to upload, but I was not that, my health was not allowing me to upload. But today I am back. So please like, share, subscribe to our channel, like the video now itself, and share it to your friends. Comment your opinions, doubts, etc. For sure I'll be replying to it. So today what we are planning is that JEE mains is coming short, like in 20 days, not 20 days, 7, right? 7 plus 10, 17, 18, 19, 20, 21, 22. In 15 days JEE mains is coming. So last 15-day preparation is that what? Learning all the organic chemistry reaction for chemistry. So we are going to learn all the organic chemistry reaction now. So first of all the organic chemistry reaction means from second year, mainly from haloalkane, haloarine, alcohol, phenol ether, aldehyde, ketone, carboxylic acid and amines. Okay. So first of all, look for from these chapters, mainly organic reactions will only be asked. Only the organic reactions will be asked. So learn it thoroughly so that you will get good marks in chemistry at least. Okay. So let us go. First of all, from haloalkane, haloarine chapter, that is method of preparation of haloalkane. So look in this. The most important method is from alcohol. Usually from alcohol. Method of preparation of haloalkane. Main method is from alcohol. That is ROH plus an acid gives RCl plus H2O. This is the most important, and the thing is that here rearrangement is possible. So do it accordingly. Rearrangement is possible, and carbocation is formed. As carbocation is formed, only rearrangement is there. So carbocation is formed. This is the important point in this reaction. ROH plus. So this reaction is also called in a special name. That is when we use the Lucas reagent in this reaction. Lucas reagent, that is anhydrous zinc chloride. We call the reaction as Lucas test. The thing is that this is the reaction for identifying what? Alcohol. So tertiary alcohol will give turbidity in immediate turbidity. For the above, turbidity means formation of RCl. RCl is a turbidity. So if it is tertiary alcohol we are using, we get immediate. If you are using secondary, we get in 10 minutes. And if you are using primary, we get in 1 hour. Primary in high temperature only we get. In high temperature, in room temperature, the reaction is not feasible. So this is about Lucas test. Okay. Yes. Now other method of preparation of haloalkane is that preparation of bromoalkane. Next one is preparation of bromoalkane. This is just to understand. We prepare it with the ROH and we can use HBr, but HBr direct formation is difficult, so we use a mixture of NABr and H2SO4, and automatically the normal reaction happen. We get RBr plus NaHSO4 plus H2O. This is the reaction. Okay. Yes. Now other reaction is with the PX3. Here the important thing is that look the byproduct. Understand the byproduct. They can ask you what byproduct you get. It's important byproduct. That is ROH plus PX3. That is phosphorus trihalide. We get RX plus H3PO3. Here we get H3PO3. Now you can balance the equation as per your need, but I am not balancing now. You just balance if you need. Now there is another reaction with the PX5, that is pentaphosphohalide, that is ROH plus PX5. This also gives us RX. Then what we get is that, this is very important, POCl3. Here we get POCl3. When we use PX3 we get H3PO3. Here we get POCl3 plus H2 HCl accordingly. If you are using Cl, if you are using Cl, usually we use Cl only. So we can do it's PCl5. We get RCl, POCl3, HCl. Very important. This POCl3 is a byproduct. But if we are using PCl3, we get H3PO3 as the byproduct. Now with phosphorus, that is ROH plus X2 in red phosphorus. Here X2 should be Br2 or I2. Chlorine can't be produced. We get RX, direct reaction. Now the next one is the preferred method, or the most preferred method. The most preferred method for preparation. Preferred method, what is it? Yeah, reaction from SOCl2. This is for a preparation of chloroalkene plus SOCl2, because why it is preferred? Because both the byproducts are gases, so it will escape it. We get the pure product. Plus RCl plus H2 HCl plus SO2. Both are gases, both will escape and we get pure RCl. This is the preferred method. Okay. Yes. Now these are the method preparation from alcohol. Now from hydrocarbon. We can prepare from alkane, alkene, alkyne, etc. So from hydrocarbon, that is itself from alkenes. The first mechanism is a free radical mechanism or free radical halogenation. The normal thing that we learned in hydrocarbons chapter. What is it? Yeah, take a R plus, you can add what? X2 in presence of H mu or sunlight, we get RX. The orientations can be different. Okay, Now next one is from alkene. Using what? HX. Addition of hydrogen halide, that is using HX. What happened here is that addition reaction take place. That is HX. We get it like this. Now from alkane itself, instead of addition of alkyl halide, now what we are going to do? Directly addition of halogen. Directly we are going to add addition of halogen. Okay, that is double bond compound. Directly we are adding Br2 in presence of, this is very important, CCl4. We get a before this thing, very important, here what is formed? A cyclohalonium anion is formed. A cyclohalonium anion. This thing will change it to, what? Dibromine. Vicinal dibromide. Vicinal means adjacent carbon. Geminal means on same carbon. What we get here is a vicinal dibromide. Okay. That comes to an end. Now what we have next? This come to an end. Now next is other type, that is halogen exchange reaction. Now from halogen exchange, exchanging halogen from a compound. This is another method of preparation. In this there are many named reaction. First reaction is called the Schwarz reaction. Very simple. From AgF you can prepare what? Fluoride, RFs. Into AgF add RX. What we get is RF plus AgX. Here instead of AgF you can use a COF2 SbF2 SbF3 Hg2F2 anything like this. Now second one is Finkelstein reaction, preparation of iodo compounds, that is Rx plus NaI. This is not Wood's reaction. Many people will think that it's Wood's reaction. It's not Wood's reaction. This is Ri plus NaX. This is called the Finkelstein reaction. And this happens in which medium? It happens in dry acetone medium. Why it happens in dry acetone medium? It's written in your textbook that NaCl or NAB are formed is precipitated in dry acetone. This is precipitized in dry acetone for forward reaction. Forward reaction. Okay. This is Finkelstein reaction. About Finkelstein reaction. Schwarz reaction is also over. Now these are the methods for preparation of what? Haloalkenes. Now preparation of haloarenes. Methods to prepare haloarene. This is a very important. First method is directly from benzene, directly from toluene. That is, into toluene you can add Fe, that is X2, that is X2 plus Fe in dark iron. You get what? You get toluene para substituted para-halotoluene. You get para-halotoluene, or you will get ortho-halotoluene, or any both you can get. Okay. Now okay, this is the first one. Second method is called a Sandmeyer reaction. Sandmeyer's reaction. This is very simple, that you know. This reaction is also very important because it's in amines chapter 2. What is doing? We take aniline. We take what? Aniline. Into that we add NaNO2 HCl in what? In 0 degrees Celsius. That is 273 to 278 Kelvin. So we get what? We get this thing, N2 plus X minus, and into this what we add? We add Cu2X2, or we add Cu2X2, not or, Cu2X2. We get aryl halide plus nitrogen gas. This is the thing. Now if we need to form iodide, the simple method is that just take this diazonium salt and just put it in a bottle with the Ki, you will get iodide. Just shake it with Ki. It's very simple. Okay. Now if you need to form fluoride, you should take what? HbF4. It is HbF4, right? One second, let me check. Yes, one second. Yes, to form fluorine, to add fluorine, we will take HbF4. This is there in amines chapter. It's not given here, but it's there in amines chapter. What happened? We get this thing first, that is BF4 minus. Now what happened? Now if we heat it, we get fluorobenzene plus BF3 plus N2. Formation of fluorobenzene. Simple. Now another reaction is there. To form as Gattermann reaction. Not Gattermann coach, it's just a normal Gattermann reaction. This reaction is also given in your amines chapter. It is not given in this chapter. Which chapter? It's not given in haloalkane, haloarene, but it's given in amine. So this we are writing it here. Gattermann reaction. It is benzene ring N2 plus X minus, copper plus HCl or copper plus HBr, you get the corresponding haloalkane plus N2 plus CuX. Okay, simple, right? Simple. So this is Getterman reaction. So for preparation from aniline itself, we have two methods, that is Sandman reaction and Getterman reaction. For iodine, just mix it with Ki. For fluorine, you have to take it with HBF4. Okay, and this is the normal method, Fe dark. Okay, normal method. Okay, yes. So this come to an end. Now we go to chemical reactions. So look, for this week we'll be like doing all the physical chemistry together, all inorganic and all organic together. So without much ado, we'll do it. Now for chemical reaction, first we have nucleophilic substitution. Look, explaining nucleophilic substitution, every reaction, a lot of the reactions given. The main ones I will just explain. So what happens here is that a nucleophile will come, and here we have, look, this is a revision class, not for new people. So for new people, we'll upload it afterward. This is a revision class. Just you can view this and go and write a mock test. Nucleophile plus X minus. This is the basic reaction, and in an NCERT one table is given. From that table, some reactions I will tell you. First one is that NaOH plus Rx. What we get? We get ROH plus NaX. This is one important reaction. Next one is this one. This reaction you have already learned it, that is Finkelstein reaction. That's also a type of nucleophilic reaction. It's also important. NaI plus NaX. Okay. Now next one is RNH2. That is amine plus Rx. What we get? We get what is the product we are getting? We are getting secondary amine as a product. The same reactions there in amines chapter that we wrote it here. We get hydrocarbon. Now the next thing is the main thing, that is Rx plus KCN. What we get? We get RCN. That is cyanide plus KX. But Rx plus AgCN, we get what? RNC, isocyanate plus AgX. Here the reason is that KCN is ionic and AgCN is covalent. As ionic, both C and N are ready to give its electron to alkyl group, but in AgCN only nitrogen is ready. So you know that carbon-carbon bond is more stable. For KCN, carbon and nitrogen both are ready. So alkyl group is like carbon-carbon bond is stable, so carbon and carbon will form the bond. But in AgCN, only nitrogen is there. Carbon is not free for bonding, so nitrogen should bond with the alkyl group. That way we get what? Isocyanate. Next one is also, another one is also an important, that is Rx plus AgNO3. Here what we get? We get RNO2, that is nitroalkane plus AgX. Now if we are using, it's not AgNO3, it's AgNO2, nitrite. Now Rx plus KNO2, that is potassium nitrite. We get RONO plus KX. This is also an important reaction. Note it. Just note it and keep. Now another one is no need. So we will be doing only this much examples. Now if we are using Rx plus lithium aluminium hydride, it's a reducing agent. So what happens is that this will be reduced to hydrocarbon. Okay. So these are the most important is these four things. These 4 things they can ask question directly. Okay, over. Now they are telling about the mechanism for nucleophilic substitution. Mechanisms. I don't have time for explaining mechanism. I will just briefly tell SN1 mechanism. It is a carbocation formation mechanism. Rearrangement possible. Racemization. Order is a tertiary, secondary, primary. Order is tertiary, secondary, primary. And anything else? Polar protic solvent. This is not there in NCRT, but just note it. It happens in polar protic solvents like water, alcohol and all. Water, alcohol and all. Okay, this is the thing that I am giving it extra. So this is about SN1 reaction. Now to SN2 reaction. Important thing is no intermediate mediate proceeds through transition state. Order primary, secondary, tertiary. Inversely proportional to steric hindrance. And most important, inversion of configuration. These are the most important things. Okay, this is about SN2 reaction. Now it is about that's about the reaction. Now there is something about optical activity that is told, optical activity, but it's not related with any reactions, but I'll just tell you optical activity. If there's a carbon, there are 4 different groups, A, B, D, E. Then what happens? Then this is called optically active. It's normally it's like that. It's optically. We can tell optically active in this case. Or you will do one thing. You take something. You take this carbon. You take this thing. This compound, you just take it. I'll just copy it, and you take the compound given to you, and you imagine a mirror in front of it, and draw the mirror image. That is, the distance should be accordingly A, D, E. Now take this mirror image and keep it upon this. Are they imposing each other? No. If they are non-superimposable, they are what? Optically active or enantiomers. They are called what? Enantiomers. If they are superimposing each other, the compound is not optically active. For example, you can take CH4 or something like that. CH3X. Now take mirror and take the mirror image. Look, if they are superimposing. Now they are not superimposing. But the thing is that you take this, you rotate it 180 degree. Rotated 180 degree means just rotate it. just rotate it like this. So you will get you can impose the mirror image. So that's about optical activity. Lot many things is given in the book. You can just read through it. Now next thing is elimination reaction. That is elimination reaction. Beta elimination of beta hydrogen. That is I'll just explain. Look, when a base when we are using a base, in presence of a base, We are heating a compound. Look, example, this compound. This carbon is alpha carbon, this is beta carbon. What happens is the base is here. It's an electron donor. This base come and give its electron to hydrogen. Therefore, hydrogen will live, and this bond will be falling here, forming a double bond. Plus what hydrogen is went to the base, salt formation, plus X minus. Okay, because this X also leaves. Okay, the main rule for this is for the elimination reaction is Zaitsev rule. It's not Zaitsev, it's Zaitsev. It is Zaitsev or Zaitsev, both are preferable. Okay, I am telling it Zaitsev rule. In NCERT it's given what? Zaitsev rule. Anything. The rule is telling that, look, I'm having a compound here, CH3, CH2, CH2, CH, Br, CH2H. Look, this compound is having two possibilities to form double bond. One, it can fall here, or the double bond can fall here. Which one is preferred? It is telling that what happens that first of all they will put the double bond. The double bond is going to fall to this side. They are telling the double bond is going to fall this side because look, when this double bond is here, to the right of this, how many groups are there? There are 2 substituent groups. To the left of this, there are 1, 2, 3 substituent groups, or 3 groups. But when this is falling to the other side, here there are 4 groups, perfect. But here there is only 1 group. The thing is that the groups in the both side should be which one is more. That's only preferred. 4 1 and 3 2. Here there is equality, so equality is preferred. Or more number of substituted carbons are there. Or you can tell something that where there is more number of substituted carbon, that is somewhat simple. In dehydroalgenation reaction, the preferred product is the alkene, which has a greater number of alkyl attached to the doubly bonded carbon. Look, don't consider this carbon. Which one have more? Here there are 3 groups attached. But if it's falling to the other side, there is only 1 group attached. Which is preferred, 3 or 1? 3 is preferred. So it will fall here, and here double bond will form. This will be not, this will be what? Not formed at all. Not formed. Okay. Yes. This is Zaitsev rule. Now there is some other rule that is very suspicious. That rule is called one second.